Okay, so here is a fake data set for a regression problem. Okay, so in a regression problem, your label or your success factor that you're trying to predict is going to be a real number, like a price, as opposed to a yes or no or ABC kind of class. Okay, so here we have the price of some houses. I guess they're in Winnipeg because they're kind of cheap. And these are your x's, okay? So this is called the y variable. And these are your x factors. And we're going to try to learn what the price is based on the x factors. Then we're going to build a model, okay, giving a weight to each column. So the area weight, the average distance weight, whether or not the house is white. Okay, so we're going to figure out these weights, learning from our historical data. Okay, build a model, and then look at our predictions based on the model and the x factors. Okay, so here's your area in square feet. Here's your average distance from a SkyTrain station in meters. This column represents whether or not the house is white or blue or red. Okay, and it should only be one across that set of rows, or set of columns. Okay, this is the predicted price. So basically, it's a linear model, meaning that we add up the various factors. Okay, so I'm multiplying area in square feet by its weight, which is currently 0. And then I'm adding the average distance times its weight, which is 0. And whether or not it's white times its weight, and so on. Okay, and that gives us our predicted price based on the model and whatever x factors are available. Okay, the error is the difference between the predicted price and the actual price. Okay, and then you take the square of the error to get rid of the negative numbers. Take the sum of squares, and then take the square root. And this gives you a number indicating how bad your predictions are. Okay, so if I gave it a weight which is close to the actual weight, that sum of square, or the square root of the sum of errors is fallen. Okay. So what we want to do is you want to minimize this. Okay, you want to have the smallest errors possible between your prediction and the actual price. Okay, and the way to do that is to adjust these weights until this number is as small as possible. Now you can do this in Excel using the solver add-in. Okay, and our objective is this square here, so M26, and we want to minimize it. Okay, so we're minimizing the errors by changing the variable cells. Okay, so we're going to be changing these weights, which is our model, to minimize the error. Okay, no constraints. Hit solve. Okay. Okay, so it's minimized that error from like 190,000 down to 5. Okay. And it's changed the weights in an intelligent fashion to minimize that error. Okay, so our model is going to be price is equal to 20 times the square footage plus 2.5 times the average distance plus a very small weight on whether or not it's white, an even smaller weight on whether or not it's blue, and a small weight on whether or not it's red. Okay, so here's the predicted price for, say, this one. This one's better. So when you multiply those weights times these values, then you get 45390, and the actual value is 45392. Okay, and your error is minus 1.6. Okay, then you could always keep your weights. You can throw away this data if you want, and you get some new data. Say it's a 2,500 square foot house, 500 meters from the train, and is blue. And you want to know what it's worth. Then your model tells you, okay, because it's kept the weights around from before, and now you have new x factors. Okay, so it should be worth $51,000. complex. Okay, so that's what regression's about. You can also use nearest neighbor to do regression. Okay, so in RapidMiner, you're going to use the linear regression operator. Okay, you can probably keep it at its defaults. Okay, then we'll return the model as well as the weights. You can use nearest neighbor. Okay, in that case, you're going to want to use probably numerical measure with Euclidean, taking a weighted. Okay, if you search for regress, and here you can see some more regression operators. Don't use logistic because that is for classification, just as a funny name. Okay, but you could try any other ones and see if you get better results. You know, if you're going to use one, maybe look up its definition and read up on it quickly, but the linear regression one should do you fine. Okay, and it would use similar kind of data as to what I have in Excel. Okay, you know, numerical or categorical, but you want to make sure that you set the role here as the label and that it's going to be real numbers. Okay, thanks.